Good morning, dears. Let's continue with our inverse Laplace with reference to the previous video where we just started inverse Laplace. Please recollect it just in 2 minutes. I will go through. We started finding Laplace of algebraic functions. Now in algebraic functions, I'm so sorry, Laplace inverse of algebraic functions. We started with inverse. Finding Laplace inverse of algebraic functions, I gave you 4 steps. I will just recollect. Our first step was we will check whether it has direct formula or not. And in the previous video, I explained you properly how to check whether it has direct formula or not. If yes, apply it. If no, we'll go for next step. So, check whether it has direct formula. If yes, apply. If no, go for step 2. What is our step 2? Our step 2 is use of first shift theorem. Now, today I will explain you when to use first shift theorem, and then I will tell you how to use first shift theorem. So, if this step is not applicable, we have to go for step 3 and step 4. And in 4 steps, we are going to complete how to find inverse Laplace of algebraic functions. So, once again I am telling you, I am not going to solve any problems over here. All these videos are just to understand the concept. This I am telling you in every video. Whenever you are given a function and you have to find Laplace inverse, there are various methods. It's easy to understand the method. It's easy to apply the method. The most important thing is you have to understand for which function, which method is applicable. And for that, I am giving you all the steps. So once again, I am telling you for algebraic, last lecture, last video we have seen, we'll check whether it has direct formula. I told you how to check. If not, we have to go for second step. Just pay attention for second step. Now in the second step, so I will have an example for that. Say we want to find out Laplace inverse of something of this type. This is an algebraic function. The moment you look at this, first thing you are going to check whether it has direct formula or not. Answer, it's very simple. Let's have here square. Whether it has direct formula or not. How to check? Now just one step I will recollect which is applicable here. You can see denominator is a polynomial, which is a quadratic rather, but it is s square, one term of s and one constant term, means it is something of this type, and in this case we don't have any direct formula. You can recollect the previous lecture. So when we don't have direct formula, we'll go for this step. And what is this step? When there is no direct formula, just try to check, is the situation like we can replace s plus a by s. When I say s plus a, please remember it can be something s minus 1, s minus 3, s minus 2, because a is any constant which is there minus 1. Okay, so if we can replace s plus a by s, and by replacing by s, are you getting standard formula? That is just checkpoint. We are not writing this. What I said is, can I replace first of all any s plus a by s? Yes, I can replace the s minus 2 by s. When I replace it, this is just a rough check. What you have to do is this. So if we replace, just see what we are getting. It is s upon s square plus 6, which has direct formula to find inverse. 4 upon this, that also has direct formula, and we can get the inverse. So this is just a checkpoint I am telling you. If you can replace s plus a by s, and not just you can replace, by replacing, please see, are you getting standard formula? If yes, we will use first shift theorem. If no, we have to go for next step. So first I will write when to use. So as I wrote, use of first shift theorem if by replacing s plus a by s, if we are getting standard formula, then use first shift theorem. So I told you when to use. Now I will show you how to use. Listen now. This is L inverse of. Now it is there in my mind. I want to replace s minus 2 by s. So remember, everywhere I have to replace s minus 2 by s, not only one place. If I replace here s minus by 2 by s, here also I must do it. So the numerator, how I am going to adjust? I am going to adjust in this way. So obviously I haven't changed it. It is s minus 2 plus 4. Denominator is 4, s minus 2 square plus 6. And now the moment we are replacing s minus 2 by s, please see here, I am replacing s minus 2 by s, simply we can't replace. When I am replacing this by s, outside I have to write e raised to 2t by first shift theorem. Now don't just memorize this. I will explain you how I got this. Listen carefully. We have seen, see, this is just rough work for you, how I am using it. We had seen first shift rule for Laplace L of e raised to at. Let me give you example. Say L of e raised to 2t into sine t. Simple example. How we find this? Please recollect the videos. I explain you Laplace how to find first shift. When to use first shift in Laplace? If it is e raised to at into some function. How to use? Just hide this. Find Laplace of remaining. What is Laplace of sine t? Laplace of sine t is 1 upon s square plus 1. And then replace s by s minus 2. Where it is s? Now you have to write s minus 2. Please recollect this which I taught you. That was first shift theorem in Laplace. Same I am using now reverse way. See what is the meaning of this? This gives me actually L inverse of s minus 2 whole square plus 1 is e raised to 2t sine t. Just from this simple example, you will understand what I had done here. How the first shift can be used in inverse. See it is, you know this answer. We have to get this. How I got this? Look at the steps. As I said, s minus 2 I am replacing by s. So it is s square plus 1. The moment I am replacing s minus 2, I have to write here is e raised to 2t. First shift always opposite sign. What is e raised to 2t? It is s minus 2. So I am just reversing the steps. I am just reversing the step. So I got e raised to 2t, L inverse of 1 upon s square plus 1, which is e raised to 2t sine t. So I got this answer. This was just simple example to understand first shift, and that's the logic I have used here. S minus 2, replace it by S. The moment to replace it by S, outside we are writing e raised to 2t. If it is S plus 2, here I will write e raised to minus 2t, and with this now you can get the answer immediately. We have, this is e raised to 2t into, so it is L inverse of s upon s square plus 6. S upon s square plus a square. What is the inverse? Cos at. Here at means it is root 6t plus 6 into 1 upon s square plus a square. What was the formula again? Sine of at. That is root 6 here upon a, and finally, we have e raised to 2t cos root 6t plus sine of root 6t. We have seen Laplace. You can find its inverse and cross check the answer. We are getting back this. So that was the first shift rule. I told you how to use. Rather, before that I told you when to use. So again I am telling you, whenever you have to find inverse of algebraic function, first step is check the standard formula. Go to the first video of inverse, how to check whether standard formula is available or not. If yes, applied. If no, you have this checkpoint. Replace s plus a by s. First of all, can you replace? And not just can you replace. After replacing, can you get standard formula? If yes, use first shift rule. If no, here I will have go to step 3 or 4. Now I said 3 or 4 means it depends on problem. Sometimes you need to go for step 3 and sometimes you need to go for step 4. I'll just write here my step 3 is use of partial fraction and step 4 is the completing square. So I have here my step 3 is use of partial fraction and step 4 is completing square. Now again it depends on the problem, it depends on the function, what you have to use. Now I will take a problem where actually both the methods are applicable. So let's have say 2s minus 1 means we are finding L inverse of 2s minus 1 upon s square minus 2s minus 3. Now I'll go again stepwise. First step, what I wrote here, take the standard formula. Do we have? No. Standard formula is only what is s square minus 3. I mean there is no term of s. We can get the standard formula, sin or cos. So no standard formula. What's the second step I give you? You have to check, can you replace s plus a by a? Is there anywhere s plus a term? No. Means even second step is not applicable. So I have to go for third or fourth. Means we have to use either partial fraction or completing square. Now I will explain about the methods with the help of this problem and then you have to decide what you have to use, partial fraction or completing square. Now let's see. So very first thing, look at the denominator. This denominator, can you factorize? Can you factorize? Moreover, I will say, can you factorize easily? If the factors are irrationals or fractions or even complex numbers, we may not go for this method. It's up to you. So I'm just saying, can you factorize this easily? Then I will say we have to use partial fraction method. Again, one more thing you have to check. Can I write this as complete square? Just recollect your school maths. If you can complete square again easily, then we'll go for step 4. So now it's you have to decide whether partial fraction is easier or completing square is easier. Accordingly, you decide the method. Now let's see. I will have here, this is L inverse of. Now first I am showing you partial fraction. So how will I go for partial fraction? What I will have here is minus 3 into s plus 1. I don't think I have to explain you the fraction. This is the fractions and now we have to go for partial fraction. S minus 3 into s plus 1. Now this partial fraction you have already done. It's very simple. It's done in school levels or maybe 11, 12 standard level. So I won't waste my time there. I hope all of you can do partial fraction. If you have any query, whatever I am teaching you, if any doubt, I have given you my mail ID. You can put me the mail and you can ask me. No issues. But right now I am just assuming you know partial fraction. And for this, if you go for partial fraction, you are going to get 4 upon s minus 3 minus 1 upon s plus 1. And so I have L inverse of this 2s minus 1 upon s square minus 2s minus 3 is L inverse of 4 upon s minus 3 minus 1 upon s plus 1. And you can say after partial fraction method, what we are getting is step 1. Can you see this? This has direct formula because denominator is linear and this is just a constant. See the points in which I give for step 1. I think I have given you 4 points. How to check it has direct formula or not. And you can check it. This has direct formula. This is 4 is a constant. This is e raised to 3t minus this is e raised to minus t, and that is the inverse. So here I have used a method of partial fraction. Now, same problem, I will try to solve using completing square. So look at the denominator first. See the denominator. You have to focus on the denominator and you have to check, can you complete the square? You may have some rough work and you may check it. See, you can have this s square minus 2s minus 3. How will I complete it? I mean, how will I complete the square? S square, again these all things you have done in your schools. Completing the square means writing in the terms of a plus b whole square or a minus b whole square. So how do we do it? S square minus 2s plus 1. This is the complete square. Plus 1, I added 1, so I will subtract 1. I am getting minus 4, and this is s minus 1 whole square minus 4. As I said, if you can complete the square easily in the sense without getting fraction or complex or irrational numbers, it's mathematically right, but it will be inconvenient to us. So we will do it if it can be done easily, means just with integers and again the school level maths. So now I can have my L inverse of 2s minus 1 upon s square minus 2s minus 3. This is nothing but L inverse of 2s minus 1 upon this s square minus 2s minus 3. Now I am replacing by s minus 1 whole square minus 4. And can you think over it now? Every time go stepwise. When I solve partial fraction, after partial fraction, I found I am getting direct formula. Here after completing square, we are not getting direct formula. But what we are getting is step 2. That we can replace s plus a by s. And by replacing, we are getting standard formula. That is most important. If I replace s minus 1 by s, you can see we are getting standard formula. So what we will do, we will replace s minus 1 by s, and again when you are replacing s minus 1 by s, everywhere we have to do. So first I will have here s minus 1, means we have added minus 2. Obviously we have to subtract minus 2, means here minus 2, I should have plus 2. So I'll get here plus 1. And now whatever first shift will I explain you. The moment you are replacing s minus 1 by s, see I replaced s minus 1 by s. Immediately before that I have to write now e raised to t, opposite sign. It is s minus 1, so it is e raised to plus 1 t. And now you can see what's the inverse. It is 2s upon s square minus 4 plus 1 upon s square minus 4. 2s upon s square minus 4, that is 2 into s upon s square minus 4. What's the inverse? It is cos hyperbolic 2t plus 1 upon s square minus 4. It is sin hyperbolic 2t upon 2. So the same problem we can solve a partial fraction also and computing square also. Now don't get confused. Same problem we are solving by using different method. We are getting different answer. No. No. This answer is in terms of sin hyperbolic and cos hyperbolic t. That was in terms of E. So if you replace this by E, everyone knows the formula. Cos hyperbolic theta is e raised to theta plus e raised to minus theta by 2. Same here with minus sign. So if you want to cross check, just replace this by E. You will see you are getting the same answer. So whichever method you use, your answer is same. You have to just see the convenience. So again I will tell you the just last 2 minutes revision of today's lecture. I will say, when there is algebraic function, our first step we have to check whether it has direct formula or not. And how to check? Please refer the previous video. If we apply it, if no, we'll go for first shift theorem. And for first shift theorem, what we have to check? Can we replace s plus a by s? And by replacing, are we getting standard formula? If yes, use first shift theorem. How to use first shift theorem? Replace s plus a by s. The moment you replace s plus a by s, outside you have to write e raised to minus t. If that is not possible, then we have to go either for step 3 or for step 4. Step 3 is partial fraction and step 4 is completing square. Now you can just check this. When you use partial fraction, you are reaching to step 1, and when you use completing square, you reach to step 2. So it depends on the function what you have to use, partial fraction or completing square. It's completely your convenience. So this was just the idea. There are various problems where you may get stuck up, some tedious problems, some need some tricks and all. But anyway, we don't have that much time. As I said here, we are just seeing the concept. Where I'm just focusing on all these videos on the methods, that when which method can be applied and how the method can be applied. You can have more and more problems, try to solve them. And again, I'm telling you, for any query, you can mail me. Please go through, practice this, solve more and more problems, and if needed, you can communicate me. So I think for this we'll stop here, and in the next video, we will see how to find inverse of logarithmic functions, inverse function, we have seen only up to algebraic function. So next we will see logarithmic function and inverse function. So we'll stop for the day. Thank you very much. Enjoy your day.